Welcome to MrCScience.com's video on limiting reactants. Limiting reactants control chemical reactions. So this deals with real-life chemistry. Say a company wants to make a certain amount of a certain chemical, they need to know how much of the reactants they need to put in. So remember, reactants are the first, products are the second. So let's take a real-life example. Okay, in the following reaction, a corporation will take silver plus nitric acid and get silver nitrate plus some water and some nitrogen dioxide gas. Silver nitrate is kind of interesting. One of its many uses is that it's a white powdery substance that when comes in contact with light will turn black. Where you've seen this happen is X-rays. If anyone's seen an X-ray, the black area is actually reacted silver nitrate. So kind of an interesting thing. So when a corporation decides to make this, now they're a little bit different than just science class. When that comes into play, one thing they care about is money. So they need silver and nitric acid to do this. Well, nitric acid is relatively inexpensive, silver not so much so. So they need to control how much they make. So let's take our silver nitrate here. Say they want to make 100 kilograms of silver nitrate. How much nitric acid and silver will they be using? Now let's start by figuring out moles. This is already balanced. It's a relatively simple balance. So let's say we have 100 kilograms of silver nitrate. How many moles of silver nitrate do we have? So the first thing we need to know is how much 1 mole of silver nitrate is. So 1 mole of silver nitrate equals what we got. We got 1 mole of Ag plus 1 mole of nitrogen plus 3 moles of oxygen. Okay, so let's go ahead and look. So silver, we find our silver here. 1 mole is 107.9 grams. So we got 107.9 grams plus our nitrogen. Nitrogen is 14 plus 3 times our oxygen. Our oxygen is 16 grams for a mole. So if we multiply this out, let's grab our calculator. Let's do our clear. 3 times our 16 oxygens plus our nitrogen of 14 plus our silver of 107.9 equals 169.9 grams. 169.9 grams. Okay, so we know how much 1 mole is. Now we've got kilograms here, so we've got to convert our kilograms to grams. This you should be very familiar with, but I'm just going to run through it really quick just in case. We've got 100 grams per 1 times, we're going to want to get rid of kilograms, put those on the bottom, grams on the top. 1 kilogram is 1,000 grams, or 100 kilograms is 100,000 grams. So now let's convert that to moles. So let's start with what we know. We got 100,000 grams of silver nitrate over 1 times. We want to get rid of grams, we want to get moles, so we're going to put moles on top and grams on the bottom. We know 1 mole is 169.9 grams. So let's use our calculator. What's 100,000 divided by 169.9 equals, we'll say 588.6. 588.6 moles of silver nitrate. Okay, so now we know how many moles of silver nitrate we need. Yeah, I'm going to just copy this. Blah. place that down here. And let's scroll down a little bit. Okay, so now, oops. You did not see that. There was nothing in this lower corner here. Okay, so we know how many moles we got here, right? 588.6 moles of, here, let's label it. Oops, grab my pen. AgNO3, silver nitrate. Okay, so we know that how many moles of silver are we going to need? Well, we're going to need 588.6 moles of silver because this 1 mole to 1 mole, that's very easy. How many moles of nitric acid are we going to need? Well, here, we know we've got 1 mole to 2 moles, so we're going to need twice as much nitric acid, or 2 times 588.6 equals, we'll use a calculator. 588.6 times 2 equals 1,177. 1,177.2 moles of nitric acid. Okay. So we know that now. What we want to do is we want to talk about limiting reactants. Well, to get a reaction to go all the way to get all the silver nitrate we want, we could put in the exact amounts of the chemicals, but it is possible that some of the silver may not find some of the nitric acid. So what they often like to do is they often like to add more than they need of one of them. Well, silver's very expensive, so they're going to want to use the least amount of silver possible. So what they're going to do is they're going to do their 588.6 moles of silver, and then they're going to use extra nitric acid. So let's see how many grams this is. So to know our silver, 588.6, we have to know how much 1 mole is, right? So let's go back to our periodic table. And silver is 107.9 again. So we know that we got 588.6 moles silver over 1. We want to get rid of moles, and we want to get grams. And I've already forgotten the number, 107.9. So we know that 1 mole is 107.9 grams. So if we take our 588.6 and multiply it by our 107.9, we get quite a bit. We have 63,509.94 grams, or let's go back to our kilograms. So let's divide it by 1,000. So we got 63.5 kilograms of silver will be needed to make 100 kilograms of silver nitrate. Now let's take a look at our nitrate, or nitric acid. So we have to know how much 1 mole of nitric acid is. So 1 mole of nitric acid, I'm writing ammonia. 1 mole of HNO3 equals, well, we got 1 mole of hydrogen, that's 1 gram, plus 1 mole of nitrogen, which is 14 grams, looking at its atomic mass, plus 3 times a mole of oxygen, which is 16 grams. After a while, you kind of get to know these. So 3 times 16 is 48, plus 14 is 50, 62, plus 1 is 63. So 1 mole of nitric acid weighs 63 grams. So let's see how much 1,177.2 moles of nitric acid is, because that's what we need. 1,177.2 over 1 times, we want to get rid of moles, and we want grams, so we know 1 mole is 63 grams. So if we multiply 1,177.2 times 63, 1,172.2 times 63, we get 73,848. We'll go 73.9 kilograms. So we need 73.9 kilograms of nitric acid. Okay. So that's how much silver we need, how much nitric acid we need, HNO3. Now what they'll do in real life then is they'll say, well, silver is expensive. We'll get our 63.5 kilograms of silver. But let's go ahead, and nitric acid is not that expensive. Let's almost triple it. Let's use 200 or 220, 200 kilograms of nitric acid. And so they'll combine that. The silver will be used up. Once the silver is used up, the reaction stops, and so you got all your silver nitrate. The good thing about here is silver nitrate, nitric acid is liquid, water is a liquid, nitrogen dioxide is a gas. Silver nitrate is a solid, so that will precipitate out. Actually, it might dissolve. It's an ionic compound. It could dissolve in water. There might be more steps responsible than that. But so this is kind of an overview of limiting reactions. So in your book is an experiment with a limiting reaction of baking soda and vinegar. Kind of a fun experiment. See if your balloon's going to explode. We'll do that in class if you're in class. Otherwise, if you want to try it at home, it's very easy. All you need is a 2-liter bottle, a scale of some sort that can read grams, a balloon, and baking soda and vinegar. Go ahead and give that a try if you want. It's nothing that will damage your home. But that's limiting reactions. If there are any questions on that, feel free to contact me at mrc@mrcscience.com. Thank you.